Alright, so here's a piece of paper. It's a sector. We've got the angle in degrees and we've got the radius. And what we're going to do basically is the straight edges we're going to stick together and that will form a cone. So you have to use your imagination. So this bit here, which is the arc length, is going to become the circle that is the base, so the circumference that is the base of this cone. So it's going to become this bit here. So circumference we know is 2 pi r. So 2 pi r, let's use big R for this one. So this can be little r over here, and big R could be this radius here. So the circumference, 2 pi r, is going to equal the arc length from the original. So let's find the arc length. Arc length we know is r theta. Our angle is 135 degrees, so let's first change 130. Oh, we can do it all together. Don't mind me, just give me a bit of room. So L equals R, theta. Theta is 135. Let's change it to radians. So we've got pi on 180. So if we do that and just put this part in the calculator, you'll get 6, and then put the pi there. You'll get 6 pi. So we know that 2 pi r is going to equal that arc length, which is 6 pi. So if we divide by 2 pi, I'll do it slowly, divide by 2 pi, you can see we're going to get 3. So the radius is going to be 3 centimeters. All right, so we know the radius is 3 centimeters because it comes from the original arc length. Now, what is the perpendicular height of this cone? So I'll put an H there. So let's have another think about, remember we're putting these two, OB and OA, we're sticking them together to form this cone. So that's going to be that slant length. The 8 is going to be the slant length. So we've got the slant length and the R value. So we can use Pythag here on a right angle triangle. So if I'm looking for H squared, I'm going to take 8 squared, take away the R squared. So remember the R squared is, so R is 3. So we've got 64 minus 9 for our H squared, which is 55. So our perpendicular height will be the square root of 55. Okay, so we've got that. So next we have to find the volume of the cone. Okay, so volume, we know the formula is 1/3 of a cylinder, so pi r squared h. Okay, so we've got 1/3 times pi. R squared becomes 3 squared and h becomes root 55, and it did say in exact form, so we want to keep it as exact. So you can see one of these 3's will cancel, so we're going to end up with 3 root 55 pi as exact, and that is units, no, centimeters. Centimeters cubed because it's volume, so that should be centimeters cubed. And then part D, find the curved surface area of the cone. So the curved surface area, remember, just comes from this bit. So the base, it gets formed, there is no base, it's kind of a hole. So that whole curved surface area is really just the area of the sector. How do we find the area of the sector? It's half r squared theta, so half, and the r is coming from here, so I'll write it down, half r squared theta. So we've got half times 8 squared, be careful there. The angle again is 135, but we need it in radians. So putting that in the calculator, we can do it as exact because this all works nicely. We should get 24 pi, and that'll be centimeters squared because it's the surface area.